thank you. I will talk about more targets, like 5 of them I will talk about. Before that, I want to point out, let me introduce myself. I'm Narsireddy Anugu. I work at the CHARA as optical system scientist. In this collaboration, I want to point out a few people who did great job, Gail Schaefer and Tyler Garner, who helped me fitting the orbits, and Anton Meran helping me on doing the model fitting, and all others on science interpretation. I will go with the first very interesting target. Jack already alluded that this target has huge disk cavity. This is the observation from the MIDI instrument in N-band, and they measure 42 milliarc second disk around it. And yeah, this is around 34 AU disk cavity from the star. We observed this the same target in several epochs with CHARA MIRC-X in H-band, and we PMOI red best fit model gives the 40 milliarc second disk in H-band, and is more or less same orientation as MIDI image. So I want to show this image that maybe that cavity is created by the planet, and it can be first generation or second generation. This observation is very interesting. Planet is detected a white dwarf, and if you see the planet is very close to the star, which is like a 2.8 AU distance. My understanding is that if the planet is there during the AGB phase, it will be kicked out to the distance from the star. But here it is very close. So probably this is due to the second generation. But also in the first generation, if it is formed in the first generation, if it is kicked out too far, it can come back to the star in elliptic orbit. It can settle down close to the star in after a few orbits. But so yeah, both possibilities can be possible. And we made the orbit of the ACR target, and one interesting observation you can make is if you compare with the N-band or H-band disk to the binary orbit, and which is slightly misaligned. And so the question is which mechanism causes this misalignment, because this binary orbit is only the semi-major axis, only 2 milliarc second, and this disk size is around 40 milliarc seconds. So it's the binary cannot perturb the disk. Maybe during the disk creation phase, or something else going on that we don't understand. There is another interesting observation, or we have in the binary orbit, we have 50 to 100 micro second level residuals, and Tyler fitted those residuals, and he made a beautiful orbit. And this can be a triple, but yeah, so if we consider the physics, probably there is another source of the astrometry, that is I think this one is more likely scenario. ACR does a pulsation in the visible. In the visible, we will see around 0.5 magnitude change. So this could cause astrometry, and that might be seen here. So there are a few questions that are answered. We probably need to do more numerical simulations and try to understand them. But yeah, if you have suggestions interpreting this data, let me know. And I will go to another target. This is also very interesting target. This one is a spectroscopic binary, which is very close, and it has emission of X-rays and jets. We observed this target with MIRC-X in more than 10 epochs, and also with VLTI. And we made disk images and also binary. We did not detect the circumbinary disk, but instead we detected the, yeah, it is very over-resolved. If you see the data is over-resolved. So we did not see the circumbinary disk, but we see the circumprimary and disk around the secondary. So we explain, so there are X-rays emitting from this source. We explain that the secondary is doing accretion, and that's why it is doing the X-rays. This is the binary orbit, and if you want to see about the misalignments, so this is the binary orbit, and the primary and secondary are kind of misaligned. But yeah, so these are yeah, we want to confirm these images with the image reconstruction as well, to see how well image reconstruction would redo the images. And another target I want to show you, this is RV tau, which will show RVB phenomenon, where a long-term drop of the flux in the RVB orbital period is equal to the spectroscopic binary, and there are many papers in the literature explaining that RVB phenomenon is due to the binary, and the binary is blocked by the disk, and that's why it's caused. But there are no astrometric orbit to explain this. So we observed this target with the MIRC-X again, and in 4 epochs, and we get disk from PMO-wide orbital fit. And this disk is very inclined. That explains the RVB phenomenon, where the star is blocked by the disk. And this is a, there is no misalignment here. This is disk and the binary orbit are closely matching. Another target is we will, this one is not studied that much with the other targets, and there is no spectroscopic data for binarity as far as I know. We observed this target with the Pioneer and MIRC-X, and Pioneer show beautiful visibility slope across the wavelengths, indicating that there is a disk. And this is the closure phase signal, so visibility, indicating the binary and the closure phase signal. And we made the orbit and the disk. They look like this. So we are trying to measure all the binary made disk cavity and sublimation radius calculations for now. And I want to end with the last target, which is spectroscopic binary. We observed this target with more than 10 epochs, and we observe, you can see here first the visibility changes with wavelength, like in the previous talk. And so we made first first disk model, and we PMO-oriented disk fit likes the spirals. So there are spirals here. We are currently working on the image reconstruction to see if this image is reproduced. and we have a lot of data. So I think we will be able to get the image, same image in model fitting and image reconstruction. We have to see which one we'll get, but yeah, currently this is the preliminary model. So my conclusions are, I think we first detect the first astrometric orbits around the post-AGB binaries of four targets. And one observation is all of the orbits are eccentric. This is already proven by spectroscopic, and these interferometric observations also prove that. And some of the targets show circumbinary disk and binary orbit misalignments. Another interesting observation is one of the target has a spirals, and the binary orbit and the disk comparison can explain in one target RBB phenomenon. ACHARA target, which is very interesting. We are currently pushing for K-band observations. The idea is to measure the ring disk flux in H-band and K-band so that we can measure the accurate mass in near infrared. Thank you. That's what I want to end. Please let me know if you have any questions.
Thank you, Narsi. So we'll take questions from the audience and online. So I'll start off with one question for you, Narsi. So this morning, during Jacques' talk, he mentioned using this new organic imaging software that helps make the image reconstructions of these inner rims more smooth. Do you have any plans on trying that software for your imaging?
Yeah, I would like to. Yeah, I need to talk to Jacques and the other person who is developing that. Yeah, that would be awesome. We have a lot of data on these targets, so should be able to do the image reconstructions.
And one more question: do your in your models, how do you take care of the SED slopes between the disk and the star?
So we fit the SED when we are making the disk. So the PM-OIRAD has the feature where we can fit the spectrum for the visibility. That I think that is the question, right?
Yeah. Okay.
Yeah,
and
we fit the spectrum.
Okay. And there's one question online from Jin Hao. Says, what is the mechanism for pulsations of ACHARA to change its astrometry?
Yeah, so I think the star, the pulsation can be asymmetric. The star flux can be asymmetric. So the star would change a few micro-arc seconds. So we here notice like 50 to 100 micro-arc seconds. So if the star is doing pulsation asymmetric, so then the start position could change with respect to the binary.
But your astrometric curve is very regular. It's periodic. I'm not sure if the anisotropic pulsation can be so stable for so long time, right?
Okay.
If it's not spherical, it could be changed very randomly. Shouldn't be so stable, right?
Seems like you have more knowledge on the pulsation. I do not have much knowledge. I'm kind of speculating this could be.
Yeah. Okay. Thank you.
Thank you.
Okay, and I think we'll thank Narsi again for a lovely talk.